My name is Kaylee Gonzalez, and I want to thank everyone for joining me this morning or this afternoon to discuss the simulation capabilities available for SOLIDWORKS users on the 3DEXPERIENCE platform. So there really is some truly exciting offerings that are now available through the platform that are really going to allow us to expand the types of simulation studies we can solve. So not only are we able to solve a wider variety of studies, but we can actually solve them faster than ever before. So when we test products virtually or in the real world, naturally we are going to explore numerous design options. We may want to evaluate how long those products are going to last and find out when and where ultimate failure may occur. And this is really not an easy task. When we are simulating numerous physics and loading scenarios, we need to collect and make sense of all of the data. This can be a very daunting task and it can be time-consuming. This is especially true when design and analysis tools are disconnected from each other. So what we are going to be seeing is that we can work in a much better method and in a connected environment through the 3DEXPERIENCE platform. So inside of the 3DEXPERIENCE platform, we have a variety of different types of simulation roles. Each role has additional apps inside of it that we can use for this kind of next level simulation. Now, these specific apps are a collection of simulation capabilities, all based on the ABAQUS technology and utilizing the Simulia solver. I want to go through a couple of the primary simulation roles that are available on the platform to give you an idea of exactly what we are seeing inside of the 3DEXPERIENCE platform. Now, one of the first roles that we see that can really expand our capabilities beyond the SOLIDWORKS desktop simulation products is a role called Structural Performance Engineer. This does contain an implicit solver. This is great for nonlinear static studies or linear dynamic studies. And of course, we can do frequency, buckling, thermal analysis. This particular role is great for doing vibration studies. So modal time history, random vibration, harmonic vibration, is all something we can do within the Structural Performance Engineer role. Now, to go a little bit beyond that particular role, we have Structural Mechanics Engineer. This actually uses a different type of solver. This is an explicit solver, which is great for any type of high impact or very fast moving dynamic simulation studies. So we can complete nonlinear static and nonlinear dynamic studies and transient dynamic studies. The Structural Mechanics Engineer role comes with another app inside of it called Material Calibration. This app actually allows you to take empirical test data from a specific material. You can load it into the app and then clean up the data and make your own kind of custom material for it to use inside of simulation going forward. This will be available not just to you, but to any member of your team that has access to that material space. Couple other items. There is a Fluid Dynamics Engineer role. Again, this is definitely more in the computational fluid dynamics areas. Everything we would expect it to be with steady state and long transient flow analysis and thermal studies. One thing I want to also point out here is I have a bullet point for parametric design studies. Parametric design studies is the terminology that we use on the platform in order to do a type of optimization study. Now, a parametric design study is also available in the two structural roles that we already took a look at. I didn't necessarily put a bullet point in there, but just for clarification, that is something that is available in both Performance Engineer and Mechanics Engineer as well. We also have a Plastic Injection Engineer role where we can predict all of our molding defects, filling, packing, warpage, and mold cooling. Again, utilizing all of the cloud computing for all of these apps. And then the last role that I want to make sure we are aware is also available is an Electromagnetics Engineer role. This is actually not powered by ABAQUS or Simulia, but it's actually powered by CST Studio Suite. This is great for low and high frequency applications such as magnets, sensors, electromechanical components, or even human exposure to electromagnetic fields. We can also analyze electronic signal and power integrity, electromagnetic interference, and of course, electronic cooling. So we are actually seeing these specific roles currently available in the 3DEXPERIENCE platform. Now, when we take a look at these particular roles that are now available to us, where do they fit in regarding perhaps SOLIDWORKS simulation desktop products, which we're very familiar with? So the simulation desktop tools are available as a complement to creating better designs. And we're still keeping that mentality when we get into these higher level simulation options. But this is actually going to allow us to do specific types of studies beyond what Simulation Premium allows us to do. It's going to really allow us to go into more of those kind of destructive tests as well through structural mechanics, fluids, plastics, and the electromagnetics. So these are still great complements to the design process. They enable simulation by anyone regardless of their role. But if you do have users at your company, perhaps you are one of them where you do a lot of simulation all the time, perhaps your company has an analyst or need to do extremely complex systems, that's where we're really excited to see these offerings on the 3DEXPERIENCE platform. Now I've gone through kind of an overview of some of the more common apps and roles for simulation on the platform. But let's also remember that all of these 3DEXPERIENCE simulation roles connect with SOLIDWORKS. We're still working in this connected environment. So what we're going to take a look at now that we have an idea of some of the roles and where they fit into the simulation and types of studies we're going to be using, we're going to have a case where our analyst, whose name is Adam, is going to be working on the Nemo submarine to satisfy safety and certification requirements. So Adam is going to be utilizing his structural mechanical engineer role to run a series of studies on the Nemo submarine design. So he has already been running a series of analyses on the Nemo battery compartment and on the skid. So he has a few remaining tasks that he needs to accomplish. First, he wants to explore variations in design variables in order to improve the Nemo design and perhaps make sure it's not over-engineered. He also needs to evaluate the durability of the design. We'll be doing that by running a fatigue study and then finding out what happens when the Nemo gets too deep, where that ultimate failure will actually occur in that battery compartment. So first, we're going to be exploring design variables that can really help optimize the design. So with a depth rating of 100 meters, it is critical that the battery compartment can withstand pressures beyond that depth to make sure that the operation will stay safe. We also want to make sure that weight and cost can be reduced wherever possible. So Adam is considering the thickness of certain areas of the design, such as the steel tube and the stiffeners, and defines those associated dimensions as parameters to be optimized. So right now, Adam is doing this inside of SOLIDWORKS, and all of these parameters are going to be saved into the model, also when he uploads the model into the cloud itself. So once uploaded, Adam can go ahead and launch the Model Assembly Design app. This app is actually part of his structural mechanics engineer role and is one of the first apps that we use in order to get the simulation process started. First, a mesh is created. The automated FEMREP recognizes the thin components of the model, creates mid-surfaces and associated shell mesh bodies, all inside of a single command. Next, Adam creates structural scenario that defines the loads and boundary conditions to simulate the maximum designed depth rating. Here, Adam is choosing his faces in order to apply his pressure as part of that design scenario. Once the simulation is run and we take a glance at the results, we can see that this is actually over-designed. So Adam is going to launch his parametric design study app to run a type of optimization. Now notice here that all of those parameters that were specified in the originating SOLIDWORKS model are now our goals of interest. These are going to be run through a maximum minimum value in order to create the optimal design. And we'll let the study do all of that work for us. Once completed, Adam can easily interpret and compare the performance of the various configurations. The best design is also highlighted. We can also rename the specific study that is perhaps the most optimal configuration and start a new study. So Adam can take a closer look at this, but we're going to take a look at some additional tasks that he has to do regarding the durability and worst case scenario. So with the design exploration, we saw how we can set up parameters inside of the SOLIDWORKS model, which are going to be included in our simulation apps when loaded into our platform SME role. And we can run that automated optimization based on those parameters. Next, Adam is going to analyze the model, the battery portion, for durability and running a fatigue study. So the pressure load on the battery compartment happens multiple times throughout the life of the NEMO. Another loading condition that repeats is the impact of the skid landing during storage. Now, to simulate the secondary loading condition, Adam creates an explicit dynamic study to accurately capture the rapidly changing stresses from this landing cycle. So how exactly does the skid come in contact with the floor? Adam really lets the solver figure that out with one simple yet powerful general contact interaction. Now, to greatly decrease the solve time, Adam chooses to run the simulation on the cloud, leveraging the high performance computational power available there. What's awesome about this is you can set a study to run and you can shut down your computer while your study runs and open your computer to see the results at a later time. It's kind of strange when the first time you do it, because we don't often think of turning our computer off, but it's a huge amount of flexibility in the ability to use the cloud computing. The stress values are within an expected range, but how many times can the NEMO withstand both this and the pressure load? So the answer to that is to set up a durability study. So we'll define the fatigue loading that's going to capture both of these events. For the explicit dynamics results, we're going to include all increments to account for the fluctuations in the response. We're also going to include both stress and strain in the calculation to improve and solve for both high and low cycle fatigue. Both sequences occur in the loading history, but they are exclusive events, meaning they don't occur at the same time. So there is actually an option to turn on or turn off inter-event transition options. It gives us the ability to run studies and information kind of simultaneously. In this, we're going to turn off the inter-event transition option. Lastly, Adam is going to define the base surface finish and solve for the results. So once this has run, the results are going to be available not only to Adam, but they can also be viewed by anybody else at his company, any other collaborators, through their internet browser interface on the platform. So everyone really gets the latest information and in one place. Again, this is really kind of keeping true with this one source of truth. We don't have to email, export anything out. Everything will be available inside of our 3DEXPERIENCE platform. We saw how Adam set up that comprehensive fatigue life evaluation, or that fatigue study. One of the last tasks that Adam needs to do is to identify when and where the ultimate failure may occur, especially if the Nemo gets too deep. We still want to make sure that this is going to be safe, so we need to know what is going to be failing and where. So leveraging the exact same study from the first scenario, Adam is going to define a Rix buckling step. This is a very well-suited step for unstable, nonlinear collapse of a structure. What's great about it is it also does not require setting up a second, more complex dynamic analysis to pull from. Processing the results from this is simple. Adam can plot the load factor and can see visually which areas of the component are actually going to fail first. These and all of the other results are still stored and maintained on the 3DEXPERIENCE platform. Everything is still stored in one place. So we have almost like this instantaneous feedback on when simulations are run for the rest of our team members. So by using the 3DEXPERIENCE platform, we're able to explore numerous design options. We can evaluate durability and fatigue and understand some of these critical loading events. These tasks and simulation studies really allowed Adam and his team with the Nemo submersible to make informed decisions and to fulfill their safety and certification requirements. Now, we've seen a couple studies on how to set them up inside of the 3DEXPERIENCE platform. But let's just take a look at a couple other types of applications that we can use regarding some of these simulation capabilities. So some of common non-linear solutions that we're able to solve for are present here on the screen. Now, the rubber fender with the large deformations, if we take a look at this, this is actually compensating for kind of self-contacts. It's actually touching itself when it is deforming. So we are actually able to compensate that using some of the complex contact sets available inside of the SPE or SME, the Performance Engineer, Mechanical Engineer roles. Again, we can also have the 3-point bending with plasticity, and then also even simulate some of the hydroforming through those thickness plots there. Now, as far as nonlinear dynamic solutions, this would be available in the mechanics engineer role. We can really compensate for high speed events that have just extreme deformations or very complicated contacts, even self contacts, as in the case of the can crushing. This is something that is kind of new territory that is now available for us, even though we're leveraging our SOLIDWORKS models. So any type of destructive or crash test is something that is kind of the wheelhouse of inside the mechanics engineer role, as you can see here, anything with impact or destruction testing. So from here, I wanted to thank you for joining me to discuss some of these simulation capabilities for SOLIDWORKS. We saw a great overview of how to create a couple different types of simulation studies, a little bit more information about the roles. And again, remember that these simulation studies are actually occurring after we load our SOLIDWORKS files up into the platform. So we're still able to work inside of this connected environment, even when working with the cloud computing on the 3DEXPERIENCE platform.